Assalamualaikum and very good afternoon to my supervisor, Professor Madhyati S. Dr. Abrahman Saili. Today I will present to you my final year project presentation and the title is Technology Application Among the Oil Palm Smallholder in Sabah. Before that, my name is Muhammad Asfar NAQIB bin ROHAIZAT. Alright, for the background of study, Malaysia holds the position of the world's second largest palm oil producer, with a significant portion of its production coming from smallholder. And the smallholder scale farmers play a crucial role in Malaysia oil palm industry, collectively contributing a substantial share to the country palm oil's output. As reported by the Malaysian Palm Oil Board (MPOB), smallholder are responsible for approximately 40% of the total oil palm plantation area across Malaysia. The Malaysian Palm Oil Board (MPOB) has formed partnership with 4 local companies to commercialize innovative technologies in the areas of fertilization and plantation mechanization. The collaboration involves FGV Fertilizer Sdn Bhd, which will manufacture fertilizer formulation specifically designed for oil palm crops. And this formulation incorporates natural nutrients and minerals to enhance the uptake of essential elements by oil palm trees. This balanced fertilizer is particularly beneficial for oil palm cultivation on diverse soil types. By utilizing this fertilizer, oil palm growers can maximize their productivity. Next is the Malaysia Palm Oil Board (MPOB) has successfully brought to market a new equipment developed in partnership with ROHAIZAT Resources Sdn Bhd, which is designed for collecting loose oil palm fruits on farms. And this innovative system replaced the traditional methods of manually picking loose oil palm fruits and placing them in buckets or bags. Instead, the machine efficiently collects loose fruits at a rate of 4.2 to 5.1 kg per minute or 1,200 to 1,500 kg per day. By utilizing this equipment, plantation can achieve higher oil yields, leading to increased profitability by minimizing the loss of potential oil from loose fruits. Malaysia human population is the current population of Malaysia is above the 33 million according to United Nations 2023. If population of human is increased, the demand of food also increase. So the agriculture sector, particularly the production of palm oil, serves as a critical source of food in Malaysia. Palm oil is widely utilized as an edible oil in the country. As the demand rises, there is a need to embrace sustainable practices and incorporate modern approach and technology to enhance the production levels. Smallholder encounter difficulties in various aspects of their operation, including crop planning, purchasing inputs, processing, and selling, mainly due to their limited financial knowledge. Another obstacle for smallholder in adopting technology is the high cost associated with it. Insufficient capital to invest in new machinery and technology, as well as the lack of funds for plantation establishment, fertilization, pest control, front cutting, and revenue collection further hinder their ability to increase palm oil production. The objective of this study are to identify the smallholder are exposed to the technology, and secondly, to identify the obstacle of the smallholder from them apply technology in their daily works. The significance of this study is to determine how many people are exposed to technology and how many people adapt to technology, which is the smallholder. And the result of this study will be useful for smallholder to work more efficient with technology and sustain their palm oil productivity. Next is limitation of study. The limitation of this study is the data collection method itself. The study relies on self-reporting or survey-based data collection methods may introduce bias and limitations. Smallholder farmers may have varying varying levels of awareness and understanding of technology adoption, which can influence their responses. Next is literature review of oil palm smallholder. Smallholder refers to farmers who cultivate oil palm in addition to subsistence crops. They heavily rely on family labor and their farms serve as the primary source of income. The total of palm plantation area managed by smallholder is less than 50 hectares. The objective of the roundtables on sustainable oil palm (RSPO) is to incorporate the smallholders into sustainability certification process with the aim of enhancing rural livelihoods and minimizing adverse environmental consequences. However, despite the benefits provided by this initiative, a significant number of oil palm smallholders in Malaysia continue to operate independently. These independent smallholders have distinct daily experiences compared to the oil palm estate owned by large businesses or plantation. Next is type of technology in Malaysia oil palm industry. Based on study Lahori et al. 2021, smart farming is an emerging approach that involves the application of technology like the Internet of Things IoT, robotics, drones, and artificial intelligence AI to manage agricultural operation. Within this context, IoT plays a crucial role in enabling data-driven and data-enabled farming processes by connecting smart machine and sensor of farms. Regarding the collection and transportation of oil palm FFB after harvesting, many tractors have been commonly used, such as Badang. This innovative tractor significantly improved the efficiency of workers by handling heavy-duty tasks involved in the collection of FFB. Moreover, its maneuverability is particularly advantageous in navigating through peat soil, enhancing productivity in oil palm plantation. So the next technology is smart irrigation for plant monitoring equipped with solar power. One of the prevalent challenges encountered in oil palm seedling nursery is the inadequate irrigation system. To address the issue of poor irrigation system in oil palm seedling nursery, a potential solution is the implementation of a solar sense-equipped micro-sprinkle system. This technology enables more efficient irrigation by considering soil humidity, temperature, and pH value. The solar sense feature incorporated into the irrigation control system application utilize evapotranspiration sunlight and temperature measurement to adjust the water quantity according to specific requirement. The solar sense system detects weather condition and temperature variations to regulate water flow. For instance, it stops the water supply when the soil is already moist, which can result in lower soil temperature due to the presence of excessive soil moisture. Next is drone for pest monitoring and fertilizer. Within the next 3 years, the use of drones in the local oil palm industry is expected to undergo a significant advancement and integration. There are several essential drone applications that contribute to smarter plantation planning. Firstly, in terms of irrigation, thermal sensor can be utilized to identify areas within a field that receive excessive or insufficient water, ensuring more efficient water management. Secondly, for tree counting and mapping, drones equipped with RGB cameras can capture images from various angles. This facilitates accurate mapping and monitoring of tree distribution. Additionally, drone can be employed for soil analysis, detecting irregularities in fields, drainage pattern, and terrain elevation, aiding in the planning of optimal seeds planting pattern. So next is benefits of use technology among oil palm smallholder. Digital technology is playing a significant role in improving farm yield by facilitating research of new varieties of palm oil plants that exhibit faster growth or higher fruit yield. According to Sambi 2019, in 2016, Sam Darby Plantation introduced Genome Select, a new high-yielding oil palm genome. which had the potential to triple the industry average by achieving approximately 11.5 tons of crude palm oil (CPO) per hectare per year. This innovative genome has undergone further improvement in its second version, making it more cost-effective, resilient to climate change, and potential tolerant to Ganoderma, a common fungal disease in oil palm plantation. Next is methodology. For location of study, the study will involve collecting data on the application of technology in the smallholder oil palm industry within Malaysia, smallholder oil palm plantation. Kuna Sabah, Malaysia has chosen as the study location mainly to the depth of existing research conducted in that particular area. Next is population and sample size. In qualitative research, the sample size of interview can be explained using three different approaches. Firstly, referring to guidelines provided by qualitative methodologies. Second is cite the sample size used in studies that share similar research. And lastly is statistical proof of dataset saturation. Next is data collection method. Snowball sampling will be used in this study. Within this strategy, existing participants in the research study are responsible for recruiting new participants from their own network of contacts. Next is data analysis. Every interview conducted in the study was transcribed to generate valuable material for analyzing the finding, and the data obtained were then subjected to a qualitative analysis using thematic analysis. So next is Gantt chart and pilot study. A pilot study is the first step of the entire research protocol and is often a smaller size study assisting in planning and modification of the main study. In this study, owner of oil palm smallholder will be piloted the interview question. By doing that, the flexibility to modify certain interview question during the actual interview was recognized. Next is expected outcomes. The expected outcomes of the study is the productivity from oil palm smallholder will increase by expose and adapting the technology among the smallholder in their daily works. And secondly, the smallholder will develop a better understanding about technology in oil palm plantation, and it is also enhancing efficiency and cost saving. Alright, this is the several references that I have been used. Alright, that's all for me. Thank you.